Welcome to Electra Mining. This is Brian Maja, a data scientist at Veeder-Root. Today I'm going to be presenting to you JEDI. Basically, JEDI uses machine learning to answer two problems. One, can I run my mining operation with minimal fuel possible? Two, can I improve my operational equipment uptimes? The space basically where we play in on the ecosystem of mining fuel and fleet is that we help you in terms of your vehicle selections. We also help you in terms of your predictive maintenance and repairs using first principles. We also help you in terms of your fuel management, and we also help you in terms of your driver supports and the likes. So where exactly do we play a role in the value chain of a mining industry? So as you can look here, or as you see here, this is the mining value chain process, and the highlighted blocks in terms of red is where exactly we play value, or we add value. We're looking at your infrastructure to say how do they consume fuel. This is the last mile end of fuel consumption. We also then look into your crushers and the like to get to see how they consume fuel. So your equipments like drills, your motor graders, your trucks and crushers as well, excavators as well. So how do we source that data? Because this is quite critical. We understand that mines are at different stages in their operations. Some mines are quite advanced in terms of the technology. Some mines are quite still low in terms of the technology. So we kind of source different data points from different sources within your business. We look into the OEM's machines. We look into your third-party devices like scanners and the likes. We look into your SAP systems to try to acquire ERP-type data. And then finally, we also have customizable interfaces where users and operators can work. And this last one is quite critical simply because, and this is the one, simply because that mining companies a lot, they currently have Excel sheets they're currently running on, and it's quite critical for them to try to avoid change management when they're getting this data into their systems. So all the systems now goes into JEDI, which is an application sitting on the cloud server, and how the user will access it is on the browser. So how we operate is that whenever we get into a mining operation or a client mine, is we first of all have to define the problem. We first of all have to validate the problem to say, is there any liters which are currently being consumed that are not consumed in the right manner, or sort of like consumed in an optimal manner? The second problem is that, is there any maintenance which is just being done for the sake of it being done? So the next step as well is then we define the KPI. So KPIs basically are there to monitor improvements. If there's any improvement in the operation, we try by all means to have those KPIs to check if there's any improvement for monitoring purposes as well. The second one is that we look at your model building as well. This is basically where we're going to apply machine learning models to try to improve how your fuel is consumed within your operation. Lastly, then we give advisory and recommendations. Some will be coming from the models directly, some will be operational improvements as well. So we'll start with the solution, and basically we'll start with the capturing interface, which we spoke about. So this is basically a use case which I'll give of one of our customers who had an Excel sheet where they're currently capturing the data, but they wanted to make sure that they use a familiar interface where they can capture the data instead of a new system where they'll be forced to change how they operate. So this is how the interface or the landing page of the system would look like. You have a site menu on the side, which basically has modules, and then you have a notification tab. Some of the notifications basically will be then being pushed to your SMS phones as well. So this is an interface basically which allows you, and this is for a particular customer who did not want to move away from an Excel-like sheet to avoid the change management, change resistance on that front. So basically this tool allows you then to even embed business rules to avoid capturing errors which may arise, especially when you're capturing such information on your system. So we embed the rules on the system or the capturing interface. Business rule, like for instance, a particular ton can be captured on the system, or there's a threshold of tons, and once you capture that wrong error or data entry input, then we can have those typos flagged or duplicates flagged on the system. So basically then we'll start on the first question, which is how do you run your operation with as minimal fuel as you possibly can? So what we do is we capture data from different sources. So we look at your mine production plans, We look at your vehicle fleet. This is hardware from IoT devices data, tracking your fuel level within your truck, your pressures and the likes, your road surface, how it is as well. We look at the weather data as well. So this is important for us because we understand that all this information impacts your consumption rate on the last mile. So basically what we have here on the consumption side of things, level 1, is that we then look at different scenarios to say, for instance, when you plan in your operation to say you want to produce maybe 50 tons of a particular commodity, and this is the resources you have on site, we then look into say, okay, fine, based on those stress tests you have, how do you then, or how much fuel can you consume? This goes into our model in the background, and in the model outputs the liters which are expected to be consumed. We also then can be able to predict different consumption level based on seasons, based on different weathers, and also based on your driving behavior of your operators within the plant. And this drives improvement and continuous improvement in your operation, which basically helps in terms of improving how you guys consume the fuel overall. The other thing is that we also consider and give our clients the model accuracy. This is something that a lot of companies don't do, but we also try to tell the minds or our customers to say, this is how good your model is, this is how far your model is in terms of the accuracy overall. The next level now is that we can also look into, on the right hand side of the dashboard, is that we can then looking at your overall infrastructure. We can predict how much consumption that will be in your overall operation as well. Next, we can also drill down into predicting consumption on a daily basis. This is quite critical, especially if you want to have short-term and most accurate possible forecasts when it comes to your fuel consumption within an operation. Now, the most interesting thing as well is that once you have predicted how much you're going to consume, is what then can I do with that insight? And this is where things get to be interesting. So we then look into, on the left-hand side, we have a variables of important drivers. So basically, these are the drivers in your operations that basically causes, that basically makes you consume more fuel. So we, for instance, here in this company, there's a production plan in terms of the tonnage which they produce. So it's important for us to know how much tonnage they, or a particular load of truck carries, because that affects your fuel consumption as well. The speed as well, which the guys are driving, at distance, idling hours as well. So the ranking basically tells you that if you were to make an intervention, for instance, on speed, it will be more impactful in terms of reducing your fuel consumption as compared to if you were to make a change perhaps on your driving mode, for instance. So on the right hand side, you have a causal diagram. So the causal diagram, basically what it tries to show you is how exactly are those different nodes within your business affecting your fuel consumption. For instance, we can see that the idling hours here at the bottom, it affects your vehicle fuel consumption directly. So which means that if once we see this, we can then advise an operator or a mine to say, you know what, when you're loading your trucks, how about you turn them off? And this is a new business rule which the mine can introduce within the business, and it will help a lot in terms of reducing that fuel consumption overall. There's other interventions which you can see, or other correlations or causal model or diagrams. Basically, this tells you the cause to say this is what causes that particular event, this is what causes that particular event, and then eventually it leads to your fuel consumption going down. So for instance, your production plan, if it is high and you tell your guys to increase your payload, that will also increase the weight of the truck. From simple physics rules, we know that the bigger or the more weight there is the more harder it is to stop the vehicle. And then, for instance, then it means there's going to be harsh braking, and then your fuel consumption will go down as well. Bigger, the more steeper the slope, the more the over-revving, and the more the fuel consumption happens as well. So this causal diagram will be there for every single equipment within your business, and it will be different for every single truck. It will be different for every single equipment, like crushers and the likes. And then you get to see how exactly fuel is consumed in a causal sequence. The nice thing about causal diagrams as well is that we'll be able to do inference to get to see the impact if we want to check the impact of a particular node, and we say, what if we do this? We can have those what if scenarios within the operation. This last one is basically now a simulation to get to see, for instance, if you were to say we reduce our idling hours by a certain percentage, how much impact and financial bottom line impact that will have on the business. So this is quite interesting because it does help you in terms of knowing exactly what's the causes and what to do and where to go to in terms of solving the problem of massive fuel consumption within your operation. The next level now is, how do you then monitor this interventions? Because it's one thing knowing exactly what to do, but it's another thing in terms of like monitoring monitoring the interventions you've made. So there's then the lastly as well, on the side as well, is we look at you optimize the routes basically of your trucks as well. So this is quite interesting because it's sort of like reinforcement machine learning models. Basically what we look at is we look at all the truck movements within your operations, what sort of routes they take, and then eventually we learn the best optimal routes for a truck to take within the operation, where the consumption will basically be as minimal as possible. Because there can be, for instance, long drive. The shortest distance connecting 2 points is a straight line as well. So there can be long drives, there can be a straight line. So we try by all means to get those optimal route points, the optimal directions to help you within your operation so that the guys can, use fuel efficiently as well. So basically on the KPIs which I've spoken about, and this is quite critical, especially when it comes to monitoring. You want to make sure that once you've made the intervention from those machine learning modules we spoke about, you then need to look into how do we monitor that impact. And these are some of the KPIs which I won't necessarily go through all of them, but they definitely do help you in terms of managing that fuel and getting to see that impact overall. So basically here we get to look at the fuel efficiency. Fuel efficiency basically just asks the question of, are we efficient in terms of how we use or consuming fuel within the plant? So we're looking at idling time, for instance. You can get to see, overall, if you're efficient over this time frame and by how much percentage are you not efficient as well. You can also get to see trends. So you can also get to see interventions to say, because we've made this change, this is basically what's happening in terms of that particular business within the business. This is also, again, fuel efficiency as well in terms of now looking at hours. So I won't necessarily go through all of them, but they definitely just tell you about efficiency and also how much idling hours and idling time, idling liters you're consuming overall. On the fuel behavior as well, here we're looking at the OEMs, like basically how much you're consuming against your OEM. So that's quite important as well because you want to make sure that you are ordering the right truck. So your vehicle selection is ideal to your mining conditions, to your fuel consumptions as well. So here we basically look at productivity to say how much do you mine with how much or with how much fuel as well. So this is quite critical to get to see relative to the production you've made overall, how much you get out of the ground. So here we basically then look into your driver behavior as well. As we've seen on the causal diagrams, some of the driving behavior can definitely affect how much fuel is consumed. So what you want to do as well, you want to now look into your driver behavior. You want to understand what are the drivers basically causing you to actually have a lot of fuel consumption. And that's quite critical overall. So the next level is now we're looking into the prediction side of things. So we're looking into physical asset management to say, okay, fine. Now that we can now save fuel or we can now mine with as minimal fuel as we possibly can, looking at our causal model using Bayesian networks, looking at other random forests like models like random forests and the likes. Now we want to look into how do we then predict machine failures and the likes to make sure that you improve your uptime as well. So most of the companies at the current moment, they are just on reactive maintenance. The others are on preventative maintenance, where they basically put on a calendar, they plan and say, okay, fine, this is what we need to do to save this device or this machine from failing. But the problem with the two or reactive maintenance is that, first of all, you have to only fix something once it's broken. which can be problematic overall. The other one, preventative maintenance, is you might have to fix something that's not actually broken. So what you want to do is you want to look at first principles like conditional monitoring to try by all means to save, to use triggers to basically tell you when to fix a machine, right? So we have a recommendation engine which basically helps you to set up dates, to set up events within within your devices, basically to tell you when a machine is likely to fail. This uses both conditional monitoring and empirical data. And the other thing as well is we then also have survival models, basically looking at your trucks. We can tell you when a truck is likely to fail as well. So looking at the historical events to say what's the probability of a truck failure and how much load can it carry overall until it actually fails. So this is just a setup on how different modules are set up. Of course, the predictive maintenance part is quite complex and involved, but we won't dive deep into this. So basically, this is an interface on how the physical asset management works, right? So you have events which will automatically pop up in your calendar, and they can also go straight into your phones, go straight into your SMSs as well, so that you get to see the schedule. So these are recommendation models, which basically tell you when a truck is likely to fail. This uses both machine learning models, recommendation models as well, and it tries by all means to tell you that there's a failure. For instance, this particular example here which we have, it says that there's an unfamiliar equipment vibration. This can help you now to see, okay, fine, there's a vibration in my machine. What do I do to try to help or to try to solve that problem? It also then predicts the date where you're supposed to make that maintenance. So you can then, it will tell you to say, next month on the 15th, try to solve this problem. This is because it also looks at your survival models to say this is likely to survive to this level or this date as well. So it also tells you again how long a maintenance is going to last for the ETA. We can also predict the ETA as well to say how long a device is going to last before it breaks down. So this is just the survival curve, an example of a graph to say how long it's going to survive, how long the mean time before failure, also just how long it will take to run before it gets to the ground, how much payload it can carry as well, the effective hours as well. This will be quite critical, and also just the overall uptime per day as well, which it can carry. So of course, post this as well, you also want to have KPIs once you have those interventions. And these KPIs are just visualizations, high level, which basically tells you the overall uptime of your machines. You get to see which ones are, you set a benchmark, of course, and you get to see, which ones are above your benchmark, which ones are below your benchmark in terms of downtime, uptime, and performance overall. You can also get to see, your performance target in terms of by shifts as well. So there's a lot of KPIs here which we can talk to. For instance, things like uptime per hour, uptime per day, uptime per shift, uptime per month as well. So that's quite critical as well. You can also get to see the performance overall overview of your machines as well, to say are they performing and how far are they in terms of your performance target as well. There's also breakdown reports as well. You get to see also the repetitive issues which are arising in your operation as well. And this is quite critical because what it allows you to do is then you can also then drill down to say what are the most pressing issues in the operation in our machines, and you can then hire the right resources and deploy them to the right places and the right problems overall. Right. So there's also then executive reporting as well, where we can talk about fuel usage. We can talk about also variance reportings in terms of the fuel consumption within your operations as well. There's also things like sites to say which site consumes more fuel and the likes. So this is just on executive reporting. This can go to on a front end dashboard within your operation, for instance, a dispatch room. So this basically will help you get to monitor and get to see all the dashboards live when there's changes, when the guys capture, or when there's equipment, when an equipment pulls data from a source, you get to see the updates live, and you can make the right decisions right there and there. Thank you so much, and looking forward to working with you guys.